Euclid's 12th proposition says that given a line and a point not on this line, we should be able to construct a perpendicular line to AB, passing through the given point. Okay, so let's see how we can do that. So the first thing that I'll do is draw a circle with center as C, and a radius could be anything. Of course, the radius should be such that it should intersect the line. If it doesn't intersect the line, then we can't. So it has to be of the appropriate radius. Okay, so which means this circle is intersecting the line at 2 points. So let's mark these intersections as E and G. Now let's draw a circle with center at E and radius as GE. Similarly, let's draw a circle with center at G and radius as GE. So if you notice, this circle and this circle, they both intersect at these 2 points. So let's connect these two with a line. So first let's mark the intersections. F and J. Let's bring in J inside. Okay. And let's draw a line passing through F and J. You will notice that it also passes C. Now let's mark the point of intersection of this line, given line, and this line. And what we are saying is that these two lines are perpendicular to each other. So we are marking the point of intersection as H. I think by this time you should have an idea as to what is the next step. Next step is to connect these lines, these 2 points, GC and CE. Now let's look at this triangle GHGC and EHC. These two triangles, I'm saying they are congruent to each other. Why? Because this GC is equal to CE. Why? Because they are the radii of the same circle. I'm saying GH is equal to HE because we have bisected or divided GE using one of the previous propositions. And this CH is common to both the triangles. So using the side proposition, we can say that these two triangles are congruent. So now what do we have to show? That these two angles, CHG and EHC, they are both 90 degree. That means this line is perpendicular to this line. Pretty straightforward now. Since we have said that these two triangles are congruent, that means CHG and EHC, they are both equal, and their adjacent angles on the same straight line. Straight line angle is 180 degree. If we equally divide that angle between these two, we get 90 degree 90. So not only have we constructed a perpendicular line to AB, but we have proved that it is actually perpendicular. Okay. Now, as I move this line, you will notice that it remains perpendicular, whether I move A or I move B. But when you are doing this, remember, you can't move it to such an extent that intersections disappear. This line, this circle is not intersecting this line. So it has to intersect. Similarly, the point that we have chosen, if we move it, it remains perpendicular. Whether I take it up, whether I take it down. Again, if I go beyond a certain point, the whole thing disappears. Why? Because the circle is not intersecting with the line. So that is proposition 12. As usual, let me remind you that I'll put a link to a PDF book where I describe all the 48 propositions of Euclid's book 1 of elements. That's it for now.